Good morning, students. This course is membrane technology. As you know, this is the first class of membrane technology. The overview of membrane separation process is basically depends upon the development of membranes. So now coming to the some definition. What is membrane? Basically, the definitions of membrane are different types of membranes. So this separation is an indispensable part of any ground stream operation in which the industries where it is a chemical, petrochemical, biochemical, food, pharmaceutical or any aligned process industries. So we can divide these separations of fluid mixture into two categories. First one is equilibrium separation and second one is rate governed separation. So let us just try to understand what is equilibrium and what is rate governed. Okay. Now, as the name indicate, equilibrium separation is a process in which the product phase are in equilibrium with the feed phase. Okay. Now, what is inherent meaning of um, equilibrium means now a system is at equilibrium if it is constant temperature, pressure and composition. The system is in stable, not changing with respect to time. So at equilibrium, the chemical potential of two phases are equal. So the rate governed separation, the separation actually happened due to difference in the rate of physical transport of species, and that is transfer of component from a resin of higher concentration to lower concentration by using some medium and under the influence of a driving force. Okay. So now coming to these, so most of the membrane separations are usually come under rate governed separation process. So these are some of the example of equilibrium governed separation like distillation membrane, distillation, absorption, adsorption, drying, and under rate governed separation process, most membrane process comes under whether it is osmosis, reverse osmosis, dialysis, filtration, or microfiltration, etc. So the basic principle, the basic principle of any separation process is that concerned amount of energy is required to separation, accumulate the separation. So, so the basic principle of any separation process is that the concerned amount of energy is required to accumulate the separation. For example, let us see there are two substances A and B, which will be mixed spontaneously. When they mix, basically the criteria. So when the uh, enthalpy when the free enthalpy of the product means the mixture is smaller than the sum of the free enthalpies of the pure substances, so the maximum pure substances. In this practice, the energy requirement for the separation will be many times greater than this minimum value, which can be which can be donated by W minimum. So the different types of separations. Here you can see the equation W minimum great less greater than or equal to these so this equation. So next coming to separation process. So different types of separation process exist and each requires a different um, each requires a different amount of energies. For example, let us take a simple example, which is production of fresh water from seawater. The desalination actually, so the desalination of seawater can be attached in many ways or many process. So the first one is distillation. So in distillation, heat is supplied to a solution in such a way that the water is distilled off. And the second is freezing, and second is freezing. The solution is cooled and pure ice is obtained. And third one is reverse osmosis. The solution is pressurized, allowing water molecules to pass through the membrane while salt molecules are retented. So fourth one is um, my electrodialysis. So electrodialysis. The another membrane process here, electric field is applied to a salt solution between the number of charged membranes, and ions are forced into a concerned compartment, leaving water molecules in other compartments. So at last, one is membrane distillation, and there is other methods also. So other methods also. In membrane distillation, heat is applied to a salt solution, causing transport of water vapor through a non-wetted membrane. So what we understand from this particular slide is, so desalination of seawater is very important process and it can be achieved in many ways. So, minimum amount of energy required for desalination of waste waters, seawater can be obtained by simple thermodynamic calculations. Here, 1 mole of solvent means water passes through a membrane. The minimum work done when the process is carried out reversibly can be expressed as in this formula. That means pi VW the equals to, so minimum W minimum equals to pi into VW, where pi is the osmotic pressure of the sea water, which is approximately 25 bars, and VW is a molecular volume of water, which is 0.018 liters per mole. So you can get 2.5 megajoules per uh, um, metric cube. There are different So there are different types of different separation process which works under different mechanism, distillation and membrane distillation. The two works in different in partial vapor pressure. Similarly, freezing or crystallization works under the mechanism of different in freezing tendency, and reverse osmosis works on the mechanism of different in solubility, the diffusivity of water and salt in membrane. Electrodialysis works under mechanism of iron transport In charge selective ion exchange membrane, membrane separation can be mm, broadly classified in membrane separation can be broadly classified in terms of physical or chemical properties of the components that can be separated. So the table will list out actual different physical and chemical properties and based upon the separation process are actually designed. So if you look at the first one, which is size, so filtration, microfiltration, ultrafiltration, chromatography, permeation, all these processes are based on sizes. And similarly vapor pressure, so distillation and membrane distillation comes under that, and crystallization comes under freezing point, and based upon the affinity, extraction, absorption, adsorption, reverse osmosis are designed um, based on charge of solute ion exchange. Electrodialysis process works based on density. Our configuration technology works, and based on chemical nature, either complexation or carrier mills and transport works. So this table tells that size and the different chemical and physical properties of solute plays an important role. And this one is deciding factor. Based on the we can decide which separation process can be adopted. So as you know, separation process, how do you basically select a membrane process. So the membrane should be technically feasible, and membrane uh, separation should be technically feasible, and separation should be economically feasible. There are two important things. So let us say that the meaning of technically feasible means, so the process must be technically feasible. That means the separation process should be capable of accomplishing a desired separation. So whatever we want to separate, suppose let us say there are components present in a solvent mixture, and we want to purify to be 95%. So I should design and develop a or adopt such a technology that give me 95% pure solute, which is my desired product. So, accomplishing the desired separation, achieve a quality product, and a combination of two or more separation processes or sometimes requires to meet such requirement, and these combination of two separation process are called hybrid technology, in which more than one unit operation are coupled together, work together. So there will be some concentration of raw material is very important. So which means a low concentration means to a high price of pure products. So then we have to go for expensive downstream purification and separation products, which are very costly. So end product should be cost will be increased basically. So we can reduce the cost of the product by improving the technical payment for separation. So we can choose a particular separation process which we will be properly efficient for to get pure quality of the product. So energy cost is is one of the value product. The energy cost should consist of only a very small fractionation of the product. So, general objectives of this separation process are: concentration means the desired component is present in low concentration and solvent has to be removed. In purification, undesirable impurities has to be removed. And a mixture is to be separated into or more desired components. Reaction medications means a combination of a chemical or biochemical reaction with continuous um, with continuous um, uh, removal of product increases with a rate of change of reaction. Okay, thank you for